Students, welcome again to the Somalwar Academy of Professional Studies Board Examination SSC Model Answer Paper 3, Subject Maths 2. The topic is similarity. We are going to solve the paper of similarity very easily because similarity is between two triangles only. We have to study not more than that much. In between two triangles, similarity will be there only if all the three angles correspondingly congruent with the other three angles of the other triangle, and if the sides are in proportion of one triangle to the other triangle, then also the triangles are similar. And the third test, which will be if the two corresponding sides include congruent, if the two corresponding sides are in proportion and including angle to them is also congruent, then we can say both the triangles are similar. So with these three basic needs of the similarity, we'll start the similarities answers which are coming in question number 1. Solve the multiple choice question, which is very, very simple. Triangle ABC and triangle DEF are equilateral triangle. As soon as they are saying that they are equilateral triangle, all equilateral triangles are similar. Therefore, their sides are in proportion as well as. If we are talking about the area, the theorem regarding area will be area of triangle ABC upon area of triangle DEF is always equal to the side square, the ratio of the side square, that is AB square upon DE square. Okay, to get this one, so area of triangle ABC upon area of triangle DEF is equal to 1 upon 2, it is given. So therefore 1 upon 2 is equal to AB square upon DE square. AB square upon DE square means 16 upon DE square. So by making the cross multiplication, we can able to get the answer, that is 4 root 2. Okay, then the next one, the correct answer is 4 root 2. In the figure, XY is parallel to BC. Then which of the following statement is true? Very simple. XY is parallel to BC means we have to use BPT. Now BPT says AX upon XB is equal to AY upon YC. But in the answer, this is not there. Okay, this is not there. So therefore, what is there? AB upon AC. AB upon AC, just by making invertendo, we can get this answer. AB upon AC is equal to AX upon AY. AX upon AY. Making invertendo, we can get this one after BPT application. The second question was the solve, and it is application part. That is, XY is parallel to AC. Once again, whenever the parallel is given, we have to think about the BPT. Come on, further. If 2 times AX is equal to 3 times BX, it is given, and XY is equal to 9, complete the activity to find out the value of AC. Now we will start with this. What is given? 2AX is equal to 3BX. Therefore, AX upon BX is equal to 3 upon 2. Using componendo, you might be asking why we want to use the componendo, sir? Because we want AB. Why we want AB, sir? Because we want to find out, sir, XY. Because we want to find out XY. The side of the triangle, full side of the triangle we want. Therefore, we need AB. And to need the AB, to get the AB, we can get AB only if AX plus BX. If we do, then what is the provision in the mathematics to get AX plus BX? That is only the componendo, and therefore we are using the componendo. AX plus BX upon BX is equal to 3 plus 2 upon 2, which will give you AB upon BX is equal to 5 upon 2. Now let us think about BCA, triangle BCA and triangle BXY. They are similar just by AA test of similarity, because angle B is common and angle X is congruent to angle A. Why they are congruent? Angle X is equal to angle A? Because they are corresponding angle when the lines are parallel. Therefore, corresponding angles are always equal. Now, we will use the property, that is, when the triangles are similar, their sides are in proportion. Therefore, BA upon BX is equal to CA upon YX or XY. Now, just by taking that one into consideration, BA upon BX already we have find out. I have told you that we need BA complete side चाहिए हमें. Which triangle? Both the triangle की complete side. तो बड़े triangle की side निकालने के लिए we have used the component law and then we are using it here. BA upon BX is equal to AC upon XY. Therefore, 5 upon 2 is equal to AC upon 9. And therefore, AC is equal to, just by making the cross multiplication and division, we will get AC is equal to 22.5. That is from equation 1. Now, question number 3. Solve the following questions. Now, what is that? In triangle ABC, observe the triangle ABC. Ray BD bisects angle ABC. As soon as one angle bisector is given, means what we are going to use? Definitely angle bisector theorem. What do angle bisector theorem says? Very simple. In the angle bisector theorem, we can say when the angle B's bisector is BD, then AB upon BC is equal to AD upon DC. This is the angle bisector. Come on, we'll go through the problem once again. Triangle ABC, ray BD bisects ABC, ADC are collinear, and DE parallel to BC. As soon as once again, DE parallel to BC means we are thinking about the ABC and ED parallel to BC means we have to think about the BPT. Come to once again the question. AEB are the collinear point. Then prove that AB upon BC. See, first only when I have said that we have to use the angle bisector theorem, there we have seen the left hand ratio was AB upon BC. Dekho, AB upon BC is equal to AD upon DC. Okay. Now let us apply the second, that is basic proportionality theorem. ED is parallel to BC, therefore AE upon BE is equal to AD upon DC. As soon as we are writing this one, we will understand the left hand side of both are equal. That is, left hand side, right hand sides are equal. When the right hand sides are equal, so left hand side is also equal, and therefore AB upon BC is equal to AE upon EB. So simple. Students, like this, they can ask for 4 marks also. Why? 2 marks also. Why? Because there are 2 different distinct theorems which you have to combine to get the answer. So therefore, it is very important sums for the point of view board examination. Next is second one. That is quadrilateral ABCD is a parallelogram. It is a parallelogram where E is the point, is on the side C. Line DE, observe, line DE, line means it is produced. DE co-produce karna hai till T, such that we have to prove, we have to prove DE into BE. Dekh lo, see the figure. DE into BE is equal to CE into TE. CE into TE. These are the sides of 2 triangles. Which 2 triangles containing these 2 sides, 4 sides, means pair side. That is BTE. Observe the BTE and observe the triangle CDE. Yes, of these 2 triangles, DE, BE, CE, TE, they are the sides. Now, if we try to prove that they are similar, if we can prove that they are similar, automatically our purpose will serve, because when the triangles are similar, their sides are in proportion. And then making the cross multiplication will give you the answer. So our aim is to prove that these 2 triangles, that is BTE and CDE, are similar. To prove these 2 triangles are similar, what we can say? One thing observing that one is the vertically opposite. That is DEC is vertically opposite to BET. Yes, vertically opposite means one angle is congruent. Now remaining thing is only we have to prove one angle is more congruent. To prove one angle is congruent, it is given that ABCD is a parallelogram. When ABCD is a parallelogram, so first step what is in the solution we have to write is AB is parallel to CD, because opposite sides of parallelogram, as well as AT AT is parallel to CD because A, B, T are collinear. If they are not collinear, we cannot able to say like this. So therefore, AT parallel to CD. As soon as AT parallel to CD and DT as a transversal, if we think, then ATD is congruent to CDT, which can be written as CDE. Okay, so therefore BTE is congruent to CDE. Why? Because they are forming alternate angle. Therefore, now BTE and CDE, when we are thinking about these two triangles, angle BTE is congruent to angle CDE because of alternate angle. Second, BET is congruent to CED because they are vertically opposite, and therefore these both the triangles are similar. That is, triangle BTE is similar to triangle CDE. As soon as we have proved that these two triangles are similar by a test of similarity, we can able to say that corresponding sides of the similar triangles are in proportion. Therefore, TE upon DE, last two letters, TE upon DE is equal to BE upon CE. Then making cross multiplication, we will get it. DE into BE is equal to CE into TE. This way we can prove it very easily, this particular. Such type of problems they can ask you for 2 or 3 marks also. Remember this one. Okay. And very easily we can able to, only the thing that which we have to do is to prove two triangles are similar. Where one is vertically opposite, we are observing. Only to think about why given thing is ABCD is a parallelogram. On the basis of that one, search alternate angle and get the answer. Next one, question number 4. What is that one? Prove that if a line is drawn parallel to the side of the triangle, intersects the remaining sides in the two distinct points, then the line divides the side in the same proportion. See, student, when this particular statement is given of the BPT, we are thinking that this is something different than whatever it is. Some different problem it is, but it is not a problem, it is a theorem. So for that, you first have to draw as per given thing the diagram. As soon as you are drawing diagram, you will be clicking in the mind automatically that this is the BPT. And to prove BPT theorem, you know everything. Now let us think about the given thing, that drawn triangle ABC. We have drawn line L parallel to BC, which is passing through AB and AC from P and Q. Now PQ is parallel to BC. Okay, then he is saying then the line divides the side in the same proportion, means that line L divide the remaining side AB and AC into the proportion, means AP upon PB is equal to, we have to show AQ upon QC. To prove AP upon PB is equal to AQ upon QC, we have to make certain construction. To make the construction, what we are doing? We are joining PC and we are joining BQ. There are many triangles. Now, from that triangle, which we have to take into consideration to prove BPT is, suppose that is triangle APQ, the which is common to both, that is APQ triangle we are considering, and PBQ, because of BQ joining the triangle which we will get is PBQ. Now, because both the triangles APQ and BPQ, both the triangles are contained in the triangle AQB. When two triangles are contained in the same triangle, by joining QB actually, we can say their heights will be equal. Their heights will be equal drawn from Q. Their heights will be equal drawn from Q. When the heights will be equal, so our first theorem says that APQ and triangle BPQ, their heights are same. Therefore, their areas will be proportional to their bases. Therefore, area of triangle APQ upon area of triangle PQB, what are the bases? for the height drawn from Q is AP and PB, and therefore that is equal to AP upon PB. Areas, reason is areas proportional to the basis. In the same manner, let us think about APQ and PQC. When we are thinking about APQ and PQC, once again the same logic we can apply. We can draw a perpendicular from P to AQ and QC, which will be same for both the triangle. So therefore, once again, the heights are same. When the heights are same, so definitely the areas will be proportional to their basis. Therefore, triangle APQ upon triangle PQC is equal to AQ upon QC. AQ upon QC, because their heights are equal, so they are proportional to their basis. Now let us think about the numerator of both the equations of the left hand side. Both are APQ, APQ. Numerator are same. Let us think about the denominator. PQB, let us see to the triangle PQB and triangle PQC. In both this triangle PQB and PQC, they are in between two parallel lines. One is line L and one is line BC. Line L is parallel to BC. When two lines are parallel, their perpendicular distance is always equal. When their perpendicular distance is always equal, means their heights are equal. Of this, both the triangle heights are equal on the support BC as a base, then bases are also equal and heights are also equal. When the bases and the heights are equal, so their areas will be equal. So therefore, hence, area of triangle PQB and area of triangle PQC, they must be equal because their bases are equal, as well as they are in between two parallel lines, so their height is also equal. So therefore, now numerator as well as denominator of the left hand side of equation 1 and the APQ and PQC's left hand side, that is left hand side of equation 2, both numerator and denominator is same, so definitely the right hand side will also be the same. And when the right hand side also be the same, that is AP upon PB is equal to AQ upon QC. In that way we can prove BPT very easily. If they are asking you theorem, at least 2 theorems they are asking in the paper, at least maximum they can, minimum also they can, at least bolna is also not the very perfect. So but one is activity based, they are asking one theorem and one theorem to prove. Normally it's not a rule, but normally they are asking like this. So be ready with the theorems to prove. Okay, the next question, that is the question number 5, which is many time came in the examination. Okay, solve one of the following. Out of 2, one of the following we have to solve. In figure, the vertices of the square DEFG, please just now you have to look to the figure. DEFG, this is the square, are the sides of the triangle ABC. ABC, where DEFG are the points which gives, are such a points which gives DEFG is a square. Angle A is equal to 90. Angle A is equal to 90. Then prove that. DE square, we want to prove DE square is equal to BD into EC. To prove it, it's not a difficult sum, but it's a long one. Listen. Now, DEFG is a square. When it is square, so its opposite sides are parallel, as well as each angles are 90. Each angle is 90. So let us think about GF is parallel to DE, as well as GF. Automatically, GF will be parallel to BC. Why, sir? When part of the line is parallel, so the full line is also parallel. Because GE is parallel to DE, that is BC's part, that is DE, is parallel. So automatically we can able to say that part which is containing DE of the segment of BC is parallel, then BC will be parallel to GE. Then BC will be parallel to GF. BC will be parallel to GF. Therefore, GF is parallel to BC. And segment AB is their transversal. See, the AB is a transversal. GF is parallel to BC and AB is a transversal. I think AGF triangle or it is written FGA. One and the same. FGA is congruent to ABC. Why? Because they are corresponding angles. Because they are corresponding angles and the lines are parallel, that is GF is parallel to BC. And secondly, FGA is congruent to GBD. Sir, why? Nothing, because BDEC, they are collinear. And hence, we are just writing the same angle with different name. So what is the name of the ABC angle in respect of the GDB triangle? GDB triangle is GBD. And therefore, FGA is congruent to GBD. Now, in the same manner, GF is parallel to BC once again, and talk about the AC as a transverse. When we are talking about the AC as a transversal, so once again, we will just think about the angle AFG or GFA. One and the same. GFA is congruent to ACB, but ACB can be written as FCE. Therefore, GFA is congruent to FCE. Once again, the reason is same, that is the corresponding angles are congruent when the lines are parallel. After that, let us think about the triangle FGA. The triangle which is upper side, FGA, and the triangle GBD. FGA and BD. Both these triangles are similar. Why they are similar? Because FAG, okay, it is 90. Okay, is congruent to GDB. Why? Because GDB is also 90. Why GDB is 90? Because GDE is 90. Why GDE is 90? Because it is an angle of square. So it forms a linear pair with GBD, and therefore GBD is also 90. So FAG is equal to GDB, which can be written as FAG is equal to GBD. Okay, then further, therefore we can say both the angles are congruent. Therefore we can say FAG is similar to GBD in correspondence when the triangles are similar. Two triangles are similar. Now in the same manner, we will think about the triangle FGA. First, once again, that same triangle with the another triangle, that is CFE in the correspondence. Now, these two triangles already we have proved. FAG is 90. So FAG is congruent to CEF. Once again, the same logic as first we have applied. CF and GFA. Have you seen? GFA is congruent to GBD. Sorry, GFA is congruent to FCE. Therefore, these both triangles once again similar by AA test of similarity. FGA is similar to CFE. Now, FGA is similar to GBD, and FGA is similar to CFE. So I think one triangle is similar to two triangles, means that two triangles are also similar. Therefore, FGA is similar to CFE. FGA is similar to CFE, as well as FGA is similar to that one. Hence, GBD is similar to CFE. Now, when both the triangles are similar, their sides are in proportion. That is, DG upon EC, DG upon C is equal to BD upon EF. Because we want to prove DG into FE is equal to EC into BD, just by making the cross multiplication. But here, we have not completed our aim. What is remaining in the aim? That DG is congruent to FE is congruent to DE. Why they are congruent? Because they are sides of the square. So replacing them will get the answer. Because DG can be replaced by DE. So DE into DE will give you DE square, left hand side of our claim. And BD into EC will remain as it is, and therefore the answer is DE square is equal to BD into EC. In this way, we can prove this problem also. Now, the last one, that is very simple, which was very easy, but they are asking for the 4 or 3 marks like this sum, because you have to click that one. वो click होना चाहिए कि कौन सा theorem, which theorem we are going to use. In the figure, point Q is on the MP, such that MQ is equal to 2, MP is equal to 5.5. NQ is the bisector of the angle MNP of triangle MNP. Find MN upon NP. MN upon NP. Very, very simple. Angle bisector theorem. For that, MQ plus PQ. MQ plus PQ is equal to MP. So putting the value of given thing, that is MQ is equal to 2. 2 plus PQ is equal to 5.5. Therefore, PQ is equal to 5.5 minus 2. That is 3.5. Ray NQ is the bisector of angle MNP, and therefore we are applying which theorem? Angle bisector theorem to the triangle MNP. So that is MN upon NP is equal to MQ upon PQ. Okay, MN upon NP is equal to, what is MQ? What is MQ? That is 2 upon, what is NP? Just now we have find out what is PQ. Sorry, NP name. PQ. What we have find out, that is 3.5, 2 upon 3.5. Now, Mn upon Np is equal to, why 20? Because to take out that point, we have put 1 0 on the numerator. Therefore, 20 upon 35, which gives you 4/7. And therefore, Mn upon Np is equal to 4:7. Thank you, students. Once again, we have completed one more paper. Thank you. Thank you very much.